Hi friends, this is Pradeep Kumar here. Today we are going to see NS3 second.cc file. We will see the demonstration as well as how to use this file. Okay, so if you want to go about the first.cc file, which is based on peer-to-peer network, so which says that there are two nodes like this. So node number 1 and node number 2. So here node number 1 and node number 2, and they just exchange with some packets. So this is what we have seen in the example. Now in this example, what we are going to do is we are going to use peer-to-peer network as well as CSMA network. So P2P and CSMA. So CSMA in the sense that carrier sends multiple access. So that means it's a LAN network. So simply called as it is LAN. So the source node will send a packet to the destination node, but the packets will be put onto the bus. So every node in the network receives that packet, and whichever node it is intended for, only that node accepts the packet. Others simply see the packet, and if it is not intended for them, they simply neglect it. So that's how this carrier sends multiple access works. So when it happens multiple access means if there are different nodes sending the packets at the same point of time, there could be collision. So that's what we have studied in CSMA CD and CSMA CA, that is collision detection and collision avoidance. There are two concepts here. So collision detection as well as collision avoidance. So CSMA leads to that. But in this example, we will be seeing only on P2P and CSMA. So these are the two things it will be seen here. So first let's go with second.cc file. The location here is under NS-3.27 /examples /tutorial. So first let me copy this file to NS-3.27/scratch. In this folder we'll be copying this file. So what I do is I'll just copy this file, cp examples tutorial second.cc scratch. So I'm just copying this file in scratch folder. So we'll see this cd scratch ls. You can see already we have done first.cc simulation, and we are going to see now second.cc. So time being, I'll just open this file and I'll show you what is the content of this file. So here this file also have been designed with this network topology. So now we can see the topology is given here, N0 N1, as we have already seen in first.cc, but N1 here is part of the LAN network as a first node, then N2, N3 and N4. So the peer-to-peer IP is 10.1.1.0 and the LAN IP is 10.1.2.0. so for understanding, what we do is we'll change this IP address as per our convenience, 172.16.1.0, and LAN I'll put 172.16.2.0. so we'll have this way, so that we'll have our own network. Okay, so these things will reflect in our source code. Okay, as we see, this is the log. First thing is using namespace NS3, as we have already seen that. So most of the components I will not be explaining it here, because we have already discussed these concepts in first.cc. so users are requested to refer back the first.cc. Then this is the second script example. So if someone sees your code, you have to know that what kind of script they have written. That's why this thing. And we have main function, argument count and argument vector, and verbose equal to true. So I'll show you what is this verbose mode. Verbose means something running in the command. See, for example, this is the verbose mode. So what we do is so ls-v. Okay, and I'll just show you later what is verbose. Okay, now we have uint 32-bit type. So here the purpose is unsigned integer 32 bits. That's what it means. So this is what uint 32_t ncsma. ncsma number of CSMA nodes is 3. It is given as 3. Please see that this is a variable name. It's very important. I'll tell you why it is important. And we have command line command. The number of extra CSMA nodes will be NCSMA. Total number of extra CSMA nodes is 3. Please, you can refer it here. N2, N3, N4 will be the CSMA nodes, whereas N1 is part of the point-to-point node or peer-to-peer. So it's not peer-to-peer, it's point-to-point. Fine. Then verbose mode, tell echo applications to log if true. So that means verbose means whatever we are doing, it should be recorded. That's what we call as verbose mode. Then if verbose log component enable UDP echo client application and UDP echo server application. So these are the two applications which will be running in this example. Now we can see if verbose, that means the verbose value is boolean and it is true. That means if true, it will print. Suppose if you want this as false, then this verbose will not be printed because verbose is false. If false, so that's why this value boolean true or false. Fine. Then we'll come here. Suppose if no nodes are there in NCSMA, so then it will be taken as one node. That's what the ternary operator here. NCSMA equal to NCSMA double equals 0, else it is 1 and NCSMA. So if no nodes are there, then the total value will be 3 nodes. Okay, now we'll come to node container P2P nodes. So we are creating 2 nodes, node container P2P nodes. P2P nodes are created. Totally we are creating 2 nodes here. Then we'll be creating node container CSMA nodes. So we are declaring a variable CSMA nodes. Please remember, CSMA node is different from NCSMA. So this NCSMA we already declared as 3 and this CSMA nodes. Okay. So CSMA nodes that add P2P nodes that get of 1. Now please understand. In this case, N0 is, suppose if I want to refer N0, maybe I'll just use the other file. So the node N0 referred as P2P nodes dot get of 0, because you can understand now N0 is referred as this, and whereas N1 is part of CSMA as well as it is part of P2P. So this can be referred as N1 can be referred as CSMA nodes dot get of 0 or P2P nodes dot get of 1. Please remember. So this can be written as, in both the case this is possible, CSMA nodes dot get 0, or it can be written as P2P nodes of get 1, because always the index starts with 0 and it is ending at 1 here, 0 and 1, whereas here the index starts at 0 here. Now we'll come to the code, you can understand. So what here happen is P2P nodes dot get 1. So CSMA nodes dot add P2P nodes dot get 1 means, so this will be added to the CSMA nodes as variable name. Then CSMA nodes dot create NCSMA. So already we have created 3. First node is been created, and later we can add 3 nodes, because this variable refer to a value of 3. NCSMA, I'll write as a command, NCSMA equal to 3, already declared. So make the first node. Okay, so totally we have 4 nodes. Okay, now we'll come to point-to-point helper, point-to-point, the helper class, the device attribute, again 5 Mbps and 2 milliseconds, that's the device attribute, and net device container P2P devices. So net device means it is a Ethernet card along with the stack. Point-to-point dot install P2P nodes, install on the P2P nodes. Then similarly we have CSMA helper, though this is what something different now, because we didn't use this the first.cc. So it's a CSMA helper class. Since CSMA helper class, you can see as per this diagram, it is a full bus, so it's a LAN. So LAN will be having more bandwidth and delay. So in that case, the data rate is 100 Mbps and it is in nanoseconds, so 6560 nanoseconds. When you convert it to microseconds, it can be around 6.56 microseconds or something. So that's a delay, so it is given in nanoseconds. So the channel attribute here is 100 Mbps bandwidth and 6.5 microseconds. And here also we will install the CSMA devices. So the net device container, here P2P device is installed on P2P nodes, and CSMA device is installed on CSMA nodes. Then we'll have internet stack helper stack P2P nodes dot get 0. So first what we do is P2P nodes dot get 0 and stack dot install CSMA nodes. Now please understand that P2P nodes dot get 1 is not installed. So I'll write down the line, stack dot install P2P nodes dot get of 1 is not installed. So that means for this line there is no need to install this stack, because in this next line stack.install CSMA nodes. CSMA nodes have totally 4 nodes, 0, 1, 2, 3. So 1, 2, 3 will be the third node. The first 0th node will be the P2P nodes dot get 1. So okay, so the logic says this P2P nodes dot get of 1 will be equal to CSMA nodes dot get of 0. So both are same. So because of this reason we could not install it, no issues in that. So don't get confused, don't include this line. So then IP version 4 address helper address. Now this what we have changed 172.16.1.0 and here 172.16.2.0. So we are installing IP version 4 interface container to P2P interfaces and assign it to the P2P devices. Similarly, in the CSMA interfaces, assign it to CSMA devices. UDP echo server helper. Now we will come for UDP echo application. Echo server, the port number let me use 1234. This is the port number I am going to use. And application server, who is the server? CSMA nodes dot get of NCSMA. So here the example here is when you see the server is CSMA nodes dot get of 3. So this is the server. So now please understand who is the server. So in this example NCSMA is 3. That means get of 3 means we have 4 nodes, get 0, get 1, get 2, get 3. So that means this is the server. N4 will be the server. I think hope you understand that. So in this case N4 is the server. N4 is the server. Okay, so the server is starting from 1.0 to 10.0. Now next thing is comes to the client. Again client the value is 1234. The port number is 1234. Again get address of NCSMA. That means get address of 3. So that means CSMA interface get the address of 3 means the third node address we are going to get. Then maximum packets is 1, interval is 1.0. Let me use 2 packets so that the maximum packets can be 2 also. Interval is 1 seconds and packet size is 1024. In case I want to increase the packet size, I can increase to 2048 bytes. Okay. Now who is the client? Application container client apps. Echo client dot install P2P nodes dot get of 0. So 0 is the client. Now who is the client? When you come to this diagram, this is the client. So N0 is the client. Okay. So N0 will be the client. Where is that? Yes. So I'll write it here. So in this case N0 is the client in the topology. Okay. Now client is starting from 2.0 and ending at 10.0. Okay. Now IPA version 4 global routing helper populate routing table. So populate all the routing tables to all the nodes. Then here now they introduce a new thing called as point to point and enable pcap all second. The name of the file second we have given, and CSMA dot enable pcap second CSMA devices dot get 1. So get 1 means CSMA devices is installed on CSMA nodes. So CSMA nodes get 1 means they want to get the packet of the second node, and the syntax is true. Suppose you, in case you want to get packets of other nodes also, you can use it. Enable pcap second get of 3 also you can use it. Okay. Now here pcap all second all means for point to point find the pcap packet capture for all. So pcap will be run using will be opened using either Wireshark or TCP dump. So Wireshark is very popular, so we can see how Wireshark uses this file second. It will create the pcap file for all the point to point channels, whereas in CSMA we have going to create for get 1 and get 3. Okay, then simulator run. So a very simple program. So once you understand the first.cc, most of these things are replicated here. Only example is it has CSMA nodes. Okay, now I will run this example. So to run this, the command is To run the example, the command is /waf /run /second. No need of any extension. So waf /run /second. Now it compiles. After it compiled, it will give you the packet structure. Yes, now you can see at time 2 seconds client sent 2048 bytes to 172.16.2.4 at port number 1234. Then at this point, then at this time, then 3 seconds, like this. Suppose, so I have given 2 packets here. So in this example, I have given 2 packets maximum value. So you can see this line here. I will change it to 1 packet, just only 1 packet, maximum packet. Now you can see, I run the same example, you will get only 1 packet transmitted between the client and the server. Now you can see at 2 seconds the client send these many packets, and this is what it comes, and totally 2048 bytes, but earlier it was 1024 bytes. So I use 3 packets now, maximum packets are 3. Now when I run this example, so if you are a beginner user, you can first use this kind of simple modification like changing the IP address, changing the port number, then changing the number of packets, and changing the delay, and then changing the packet size. So these things are bandwidth, delay. So these parameters you can change first in the beginning, and later on you can modify the source code. So that is the best way for you to learn the complete architecture of the networks. Okay, now this is, let me use 3 packets now. No issues in the 3 packets. Now I will check the files. You can see the file name is second 2.0 pcap, second 4.0 pcap, 0.0 pcap, 1.0 pcap. So there are so many files I have created. Okay, so time being I delete all the pcap files. I'll give some other names. Okay, so what I do is, here for P2P I'll use P2P. Here I use CSMA 1. Here I use CSMA 3. I use file name 1 and 3. So for a better understanding I can use that, so that in the beginning you need not confuse. Now I will run again. This time when I see P2P 00 pcap, P2P 1.10 pcap, that means between node 0 and 0 and between node 1 to 0, the packet capture, and CSMA, you can see CSMA 220 and 420, because we have created only get device of node number 1 and node number 3. That's what we have done. Okay, get 1 and get 3. That's why it is showing this. Suppose if I want to open this file, Wireshark P2P 1-0.pcap. Now this is how this packet structure works, comes like this. So you can see IP version 4. What is the IP version 4? What is the frame structure, encapsulation, what? So your entire packet type you can able to analyze, and point-to-point protocol, IP version 4, and header length. What is header length, and differentiator services, and flags. What are the flags affected? What are the flags set or not set? Time to live is how many hops? It is totally 64. What is the protocol? UDP. The protocol number is 17. What is the source address? What is the destination? 1.1 is the source, 2.4 is the destination, and data, and the size of the data. So data we didn't use anything, because mostly data values are zeros only, because there is no data we have sent, only packet size we have sent. So this way we can able to analyze the packet. And here it is UDP. Now UDP, about UDP, because we have sent UDP packets, and encapsulator type, and epoch time, then point to point, then internet protocol. So the same thing in UDP also, and data again 2048 bytes, so completely zeros, and source port number is 49153, destination is 1234, the length is 2056. That includes 8 bytes extra, checksum missing. So it simply just show you the packet, because we didn't do much about this, just 3 packets. Okay, so this is how the values are being read. So TCP dump, if we have the N TR, then P2P -1 hyphen TCP $N$T $R hyphen R 1.0. So this also will read like this. So reading from file and linked. This is how the command we use, TCP dump -t. So before Wireshark came, when people were using Unix, they used TCP dump command for reading the packet capture file. Okay, so this thing. Now the same thing I use Wireshark CSMA. I'll use the CSMA -3-4. Okay. So these are the CSMA. So CSMA, you can see they have ARP also, because address resolution protocol, to find out to which node the packet is intended for. So that's why we use ARP also. So address resolution, you can see frame number 6, 64 bytes on wire, Ethernet 2, what is the source, destination, what is the padding, frame check sequence, and ARP reply. So hardware type is Ethernet, IP version 4, hardware size 6, protocol size 4, opcode reply 2, MAC address. So like this we can able to read the packet. And there is one other thing in this is we can check the IO graph. In statistics we can check something called as IO graph. It will show you how the IO graph is being used from starting time to the ending time of simulation. So it will also show you, it shows all the packets. Similarly, I can check CSMA 1. I'll check the IO graph for this also. Yes, you can see this is how the IO graph. Similarly, I can check for P2P2 statistics IO graph. Yeah, IO graph, we can see peer to peer. The packet didn't go down, so it is in a straight line. So this is the basic simulation. Now we'll come to network animation. Network animation here. So now what we code is, first we have to include the header file. The header file is #include NS3/NetAnim -module.h. Then you bring it down here. Here we will write animation interface anim, the name of the file, second.xml. I will use the name second.xml. Any name you can use it. So anim dot set constant position. So what do we do is P2P nodes dot get of 0, because this is very important. 10.0 comma 10.0. Why it is important is the node number names we need to know. So sometimes students usually use lowercase instead of uppercase letters. So P2P nodes like this, instead of that I can use CSMA nodes. Please see that instead of this small capital N, if I use small n, it will be error. Okay, so please be careful in selecting the variable names. Okay, get 0 and 20. So I copy this line 3 times. I'll paste 1, 2 and 3. I'll use 30, 40, 50. Maybe I can increase this also, 20, 30, 40, 50, so that you can able to see how the packet moves from client to source. See now in this example what I have done is P2P nodes are get 0, I put the location 10, 10, and CSMA nodes are get 0, 20, 20, 30, 30, like that. So this node is only one node that is very common with 2 different variable names. So either I can use CSMA nodes or I can use P2P nodes dot get of 1 also I can use. I can use both the way it is possible. So maybe if you want you can check it. So to run this example again, WAF scratch. Now after I run this example, it will create a file called as second.xml. Now it will always give a warning on mobility, constant mobility, because they are wired nodes. No need of giving constant position for a wired node. So that's why it is giving error. Now we can check it. Second, here the file is there, second.xml. Now how to run this file? /NetAnim. Please remember NetAnim, the file is available in NetAnim -3.108 folder. Inside that we have a file called as NetAnim N caps and A caps. So open it, then second.xml. Yes, open. So now you can see in 240123 something like that it will. Now I'll go with the slow simulation, then start this. Now you can see 0, the node is sending the packet. Totally I have given 3 packets, so the client will be sending packets to the server 3 times. See second packet. You can use the fast simulation also in case you will be fast. Now we can parallel, you can check the time also here. This is a third packet. 2 packets gone. Now this third packet comes up, and every time it comes, the server number is, this is the server and this is the client. Okay, so anyway, so this is how the simulation works, and here this is statistics. Here it is a packets, you can see 0 to 1, so first time it is sending, and second and third packet, so 3 times it is sending, and the arrow mark is on both the side, that means the server is also responding. And here we can see this is how the way the table comes. So from 0 to 1 at time, from 0 to 1 at time, and 1 to 0 this time, 1 to 0 this time, and 0 to 1 3 this time, and 0 to 1 again this time, 1 to 0 1 to 0 0 to 1 0 to 1 and 1 to 0. So between these two nodes how the transmission happens. Okay, so this is how the way the animator works. So let me close it. Okay, so I have closed it now. So now what we do is we'll go for Ascii trace matrix. So this is the next thing we'll be going for, Ascii trace matrix. So no need of adding any header file here, directly we can add the code here. Ascii trace helper, Ascii, I create a variable name called as Ascii. Then so we have 2 variable names in the helper class. One is CSMA, another is point to point. Please either point to point the variable name you can see, or better you can copy this, Control C. I copy this, I come here, so dot enable Ascii all, Ascii dot create file stream. The name of the file I can use is p2p.tr. Already I would have tried for the first file, so let me use point to point.tr. I use this name so that you will not have any confusion. So Control C, then Control V. Here now CSMA dot enable Ascii all create file stream CSMA2.tr. that means this is for the second file. Okay, so I create these 2 files. So this is Ascii trace matrix. I'll run the example again. So when it is compiled, yes, it is compiled, it shows you the output also. Now I can check there is a 2 trace file created, csma2.tr, and there is one more file, p2 point to point, yeah, point to point.dr. So these 2 trace files have been created. Now we will see what is the throughput analysis of only on the CSMA and only on the point to point. For that we have to go to a file called as trace matrix. I already added trace matrix, so please refer to first.cc example. I have given the description there, java space -jar trace matrix.jar. So trace matrix, it's a jar file, it's get opened using the command java space -jar trace matrix.jar. file, choose file, here NS all-in-one, NS 3.2. Okay, now it will show you all the trace files. Now we need CSMA first. Let me use CSMA and execute analysis. So total lines on the file is 52, total enqueued is 16, sent packet 16, received 20, no dropped packets, and time of analysis 0 seconds, and nodes. So node number 1, if you want you can check, node number 2, 3 and 4. So as you remember, the CSMA have totally 4 nodes, so it will show you all the 4 nodes, but the first node is common to P2P as well as CSMA. Now we can check the throughput. So this is the throughput of node number 1, and node number 2 and 3 doesn't play any role. The reason being they were not either source or destination node, they were just there on the LAN channel, that's it. But here the node number 4 is a server and node number 1 is common between point to point and the CSMA. So that means node number 0, the P2P node of first node is sending the packet to this node. This node takes the packet and send it to the LAN, and this node receives it. That's why the other two node doesn't have any throughput or output. Now little results. Here we have this lambda, EFW, EFN, EFNW. So this value we can use it. As I already mentioned, I do not aware of what is this values about. If you have any interest, you can please check it in the literature. And streams, I can have UDP stream. So here we have complete UDP about it. So stream details. Okay, nothing was mentioned. Yes. So this is how we can able to find the throughput of these two nodes. So this is on trace metrics. So we have network animation, we have Ascii trace metrics, and we have Wireshark also. So in this example we have seen trace metrics, Wireshark, NetAnim. So we have seen all the three things in this example. So please make use of this. So this example is available in the cloud directory where I will be posting this code. So check the comment section of my video. The file will be available for your download. So thanks for watching this video. Please subscribe to my channel and please share it to your friends for making this channel popular in networks. Thank you. So refer my website also, nsnam.com and youtube.com/TS Pradeep Kumar, or search as Engineering Clinic. Thank you.